Welcome to another video. In this video, I'm going to be making this UI. Now this is not a tutorial on making a beautiful UI, but this is an introduction to two different but very important topics. First, Cupertino package, which is required when you create an application focusing on iOS users, and second important topic is Bloc pattern, which is short for business logic component. Now Bloc pattern is an architectural pattern that allows you to write apps in such a way that the code for your UI is separated from all the business logic that your app may have. Okay, let's try it. So first of all, you can see that this is just a little bit modified version of the basic app that you get to see every time you create a new project. So I'm going to click on this floating action button and the count increases, and it keeps on increasing as we press it. Also notice that there is a switch button right here that says switch to iOS. Let's click on it, and there we go. We now have an iPhone. Well, at least an interface. So notice that the fab is vanished. Fab or floating action button is vanished. Well, that's because in material design, the basic usage of fab is to perform a primary and frequent action and gain users' attention. Whereas a mild Cupertino counterpart of a floating action button is the action widget that you see on the app bar. So if I click on that, you can see that the count increases. Also notice that the value of this number remains saved even when we switch the UIs. So let's see how all this works. I'm going to head back to VS Code, and I just created this project. So I'm going to run it in debugging mode using the F5 shortcut key. Okay, now that we have the app installed, and you can see that it's just a simple application and it does everything that we are going to be doing anyways. But let's see how it does that. In here, you can see that a function called increment counter is what's responsible for increasing the number on the screen. So whenever the floating action button is clicked, a setState method is called, and it changes the state of the widget that contains the count variable. To be honest, what they're doing is perfect, and there's no fault in using setState for something like this. But you need to understand that why should we not use setState as the project gets bigger? And why is there a need to follow an architectural pattern? So first, let me answer why not setState. Well, because suppose you have this tree of widgets and you need to change some value over here. So what you would do is simply call setState method for this specific widget. But what setState would do is it will render the whole widget tree and update all the elements, and that is a big performance hit. And as developers, our job is to make efficient products, and this solution is not efficient. Enter Bloc. Short for business logic component. As I said earlier, Bloc is an architectural pattern which allows you to keep your business logic away from your UIs, and I'm going to show you just how. But before diving into Bloc, you need to understand two more things: streams and sinks. Streams are the components that you may define at one part of your app and then add data to it at some other part, and then you can listen to this data asynchronously somewhere else. And the data that stream passes is asynchronously updated on your widget using the stream builder widget. Of course, all these long sentences might not make sense to you right now, but it would make more sense when you completely watch this video and come back to this part. You'll probably be able to visualize all this. Moving on to sinks. Now sinks are the components that are used to add data to the streams, which means that sinks are used to modify streams. Okay, enough of this theory. Let's go back to VS Code. So first of all, I'm going to remove all these comments. Therefore, I'm going to press Ctrl H. And then over here, first I'm going to enable this regex option, and then I'm going to write // ... So this selects all the sentences which begin with a double slash, and then I'm just going to press this button. And there we go. Now to reformat this code, just press Ctrl-Shift-F. Now we are ready to get started. So the very first thing that I'm going to do is import Cupertino.dart package. Now we're going to be making use of stream builder widgets twice in our project. So you're going to see the Bloc pattern being implemented twice. So I think you'll get a really good understanding of it by the end of the video. First, I'm going to remove the theme data from over here, and I'm going to create a folder called Bloc. And then I'm going to be making two files. First, counterprovider.dart, and second would be counterblock.dart. Now, what are these counterprovider and counterblock? So counterprovider is what will contain the logic for updating the counter, and then it will provide the updated value to counterblock. And then counterblock is responsible for retrieving that count from the counter provider, and it is also responsible for making streams. So let's go into counter provider, and I'm going to create a class called counter provider. Then inside of it, I'm going to make a variable named count and initialize it to 0. Then I'm going to be making a function called increase count, which would return count plus plus. So as you can see that the provider is responsible for providing the value of count through the increase count method. Now come over to counter block. So over here, first I'm going to import the counter provider.dart, and I'm also going to import the Dart async package since streams are asynchronous. Then I'm going to create the class counter block, and I'm going to create a stream controller by saying stream controller counter controller and initialize it like this. This stream controller helps us in actually getting the stream, and then it also helps us in modifying the stream by putting data into the sync component that I talked about earlier. Then I'm going to create a reference variable of counter provider class and name it provider, and then I'm going to initialize it with counter provider object. Now we need to make a stream, so I'm going to write stream get count, and it returns a stream using stream controller that we just made. So I'm going to write counter controller dot stream. Now remember, in this block pattern, the buttons do not directly talk to the counter provider to update the count value. It would rather talk to this counter block and tell it to update the count value. So let's see how that happens. So I'm going to create another function named update count, and inside of it I'm going to write provider.increase count. So now the floating action button in our UI would call for this update count method, and this update count method would in turn call the increase counter present inside of the counter provider.dart file. So the value of count updates. Now you might be wondering that why don't we directly talk to counter provider instead? Well, simple. It's because counter provider does not have the stream, but counter block has it. So our update count is not yet finished. We have the updated value of count, and now we need to pass the updated value of count into our stream. So I'm going to write counter controller.sync.add, and this is how you make use of the sync component to modify the current stream and add data to it. And inside of this add component, I'm just going to pass the value of the count by writing provider.count. After doing all this, we also need to dispose our streams. So I'm going to write void dispose, and inside of it just write counter controller.close, and that's enough to close our stream controller. In fact, that's all we need to do for our counter block, except for one thing. At the very bottom of the file, I'm going to create a final variable named counter block and initialize it to counter block class object, and that's it. So we have our counter provider and we have our counter block. Now let's go to main.dart and bring it all together. So at the top, I'm going to include block/counterblock.dart and block/counterprovider.dart. Now I'm going to go to increment counter method, and in here I'm going to write counterblock.updateCount. This counterblock variable refers to the object of counterblock class that we just made, and the update count method increases the value of count and then fetches the updated value from the provider and then puts it on the sync. Okay, so now we are able to make changes to our stream. Now we need to display those changes in our UI. Also make sure to remove this counter variable from here since we won't need that anymore. So instead of the build method, just extract this center widget and name it counter, and then come over to this counter. You can see that it's just a stateless widget. Now to display the data from stream, we're gonna need a widget called stream builder, and stream builder only works inside of stateful widgets. Therefore, we would need to make this counter widget a stateful widget. So I'm gonna do that by clicking on this icon and selecting this option called convert to stateful widget. And the only thing that we need to change over here is this text widget. So I'm gonna remove it from here, and I'm gonna write stream builder. Then it takes a stream, and I'm gonna pass the stream that we previously built using counterblock.getCount. Then I'm going to pass in some initial data which the widget shows before the stream takes over it. So I'm going to write counterprovider.count, and this will retrieve the default value of count from counterprovider class. And then I'm going to write builder, and it takes context and snapshot. And over here we are going to return text, and in the place of text I'm going to write snapshot.data just like this and pass in some style. So for style I'm going to write theme.offContext.textThemeDisplay4. Okay, now I'm going to hard restart the app and see if it works. There we go, it does works. the counter gets updated just as we desire. So what's happening here? Well, it's fairly straightforward, although not as straightforward as writing a setState function. So we have this provider class which has a count variable, and then we have increase count function that increases the value of count. And by the way, this is our business logic. So you can see that how far away we took it from we took our business logic from our UI. Then we have a block that creates a stream controller, and it's responsible for creating a getter, which means it basically creates a getter to get a stream from the stream controller. And then we have an update count method which works as a medium of communication between main.dart and provider.dart. Also, it fetches the updated value of count from provider and puts it on the stream using the sync. So that's it. Are you still confused? Well, let's go over it once again. In fact, instead of going over this once again, I'm rather gonna do it once again. So now I want the user to experience both Cupertino and material design on the same device, just on a click of a button. So let's start. Again, I'm going to create a provider first by creating a file called switchprovider.dart. Then I will create a file named switchblock.dart. Now inside of the provider file, I'm going to create a class named switchprovider and create a variable called bool isIOS and initially set it to false. Then I'm going to create a function called switchIOS and return isIOS equals to not isIOS. So this will basically set the value of isIOS to its complement. Now I'm going to go over to switch block, and here I'm going to copy everything from counter block just like this, and I'm going to paste it over here. And I'm going to change the name of the controller to OS controller and change the class name here to switch provider. Then I will change the name of the reference variable or getter for our stream and rename it to getOS. And to get the stream, I'm going to write oscontroller.stream. Then I'm going to rename this function to switchOS and call for the function which is responsible for switching the OS by saying provider.switchOS, and then pass the updated isIOS value to our stream using sync. So I'm going to write oscontroller.sync.add, and instead of that I'm going to pass provider.isIOS. Then in the dispose method, I'm simply going to replace this controller. And then finally, I'm going to create a variable named switchBlock and initialize it to this class object. Alright, so our work for both switchBlock and switchProvider is complete. Let's go back to main.dart and see what do we have to do now. So in main.dart, we would have to change a large amount of things now. Alright, so first I'm going to create the stream builder as the root widget of our app. So for that, I would need to convert this my app into a stateful widget, since stream builder only works under inside of a stateful widget. So I'm going to be doing it by clicking on this bulb again and selecting the necessary option. And there we go. Now I would pass the stream in our stream builder by writing stream switchblock.getOS. And then I'm going to pass the initial data as initial data switchprovider.isIOS. So here we are accessing this isIOS variable directly by using the provider class object. Then I'm going to write builder, and just like last time, I'm going to pass this context and snapshot, and I'm simply going to say return my home page. And I'm going to pass this title, and then I will pass another argument called isIOS, which will take the snapshot.data as its value. So here isIOS is simply a boolean argument that decides the type of UI to be built based on the current value of isIOS. Now I'm going to come down to my homepage class, and here I'm going to declare a boolean variable named finalBool isIOS and initialize it in the constructor, and I will also mark it as required, so that would get rid of the error that we had. Now instead of the build method, we would decide the type of the app that should be rendered on the screen based on the type of the OS. So I'm going to remove all the code present inside of this build method, and I'm going to write return isIOS Cupertino app material app. So this means that if platform is iOS or the value of is iOS is true, then render a Cupertino app, or else if the is iOS is false, which means that platform is not iOS, then render a material app. Now let's start working on Cupertino app. So first I'm going to set the debug show checked mode banner to false and set its home to Cupertino page scaffold. just like that. Just like there is a scaffold widget for material, there is a Cupertino page scaffold widget for a Cupertino app. Then this page scaffold takes a navigation bar. And I'm going to pass a text for the middle argument, and instead of the text, I'm going to pass widget.title. So the title that we pass is printed on the top of the iOS style navigation bar. Then I'm going to write trailing. So this trailing basically configures a widget which is rendered at the very right of the navigation bar, which you can see in the finished version of the app. So I'm going to write Cupertino button, and I'm going to pass increment counter to the on press. Then child icons.add, and I'm going to set the padding to edgeinsets.all 0. Since a Cupertino button has a large amount of padding by default, so we need to explicitly set it to 0. Then inside of the Cupertino app, I'm going to pass a class called adaptive body, and I'm going to pass the value of isIOS by writing isIOS widget.isIOS. Great. Now I'm going to go down to material app, and here as well I'm going to set the debug show check mode banner to false, and it has pretty much the same code that we removed earlier. So at home we have scaffold, then we have app bar, and app bar has title text widget.title. Then we have floating action button whose on press is set to increment counter, and child is icons.add. And in here as well I'm going to write body, adaptive body, and pass isIOS widget.isIOS. So now that we have both layout for Cupertino app and material app, it's time for us to make an adaptive body. I'm going to come down here and I'm going to create a stateless widget and name it adaptive body. Then I'm going to create a variable called final bool isIOS, and then I will create a constructor, and here I will initialize the isIOS variable just like this, and I will mark it as required. Then I will override the build method, and I'm going to return the center widget, which would take a column as a child, and I will set the main axis alignment as main axis alignment.center, and inside of the children I'm going to pass counter, size box of height 30, and an adaptive button. This adaptive button also takes the isIOS argument, but I'm not going to be creating a named parameter for it. I'm rather going to pass the isIOS value directly to the adaptive button. By the way, adaptive button is nothing but this button which has separate styles based on the platform on which it is rendered. I'm going to leave the counter widget as it is. Then I will create another stateless widget with a final boolean variable named isIOS and a constructor where I will initialize this value. Then inside of the build method, I'm going to write return isIOS Cupertino button material button. So it means that if isIOS is true, a Cupertino style button is rendered, otherwise a material style button is rendered. Now the Cupertino button would take a child text, switch to Android, and I will pass a color to it. Also remember that Cupertino package comes with its own set of colors, so to access them you need to write Cupertino colors.activeBlue. This is the platform specific blue for iOS. And then I'm going to set its on press to switch operating system, as this button is responsible for switching the operating system for us. Then inside of the material button, I'm going to pass a child that says switch to iOS, and I'm going to give it a style, text style, and set color to colors.white. And then I'm going to set the color for the button, so I'm going to write colors.blue. And then in the on pressed, I'm going to pass switch operating system. Now at the top, I will create the switch operating system function, and I will simply write switchblock.switchOS. And here the switchOS function is called, which calls the switchOS function of the switch provider class, which toggles the value of isIOS variable, and then passes the modified value back to Bloc, which then places the modified value of the block onto the stream. And that's it. I guess this should work. Okay, so I'm going to perform a hot restart and take a look. So I'm going to press the plus button and the counter increases, and now I'm going to click on the switch button, and there's an error. Well, the error says that the stream is already being listened to. Well, the most common form of the stream can be listened only once at a time. So if you try to add multiple listeners, it will throw an error. And in this case, we do have multiple listeners. You might be wondering that which stream is being listened multiple times. Well, it's this counter stream, because We are listening it inside of the Cupertino app, and we are listening it inside of the Material app as well. So to solve this problem, you just have to write streamController.broadcast in the counter block.dart. And now I'm going to hot restart the app again and click on this button. And there we go. We have the Cupertino app as well. But there's still one more problem. Well, what is that? See, if you click on this plus button, the value of the counter increases. But as soon as you switch the apps, the value is set to 0. Now if you click on the floating action button, you can see that the value increases just from where we previously left off. So I'm going to come back to the main.dart and check the problem. So this problem arises due to the fact that we have passed count variable as initial count for our stream builder. And inside of this counter provider, we have set the count to 00. So every time the app is changed, this 0 is picked. So that's why it's basically set to 0 every time. So to solve this problem, I'm going to create another variable inside of this provider class, and I will write int current counter equals to count. But this creates another problem. So to solve that problem, I'm going to make the counter variable static. Now this problem is solved, but making count static would lead to some more problems in the counter block. So let's solve them as well. This situation kind of reminds me of this meme which you might have seen as well. Alright, over here we cannot access the count variable using the class object because the count variable is not marked as static, which means that there's going to be only a single copy of it for all class objects. So we can access the count variable directly using the class name. So I'm going to remove this provider and I'm going to write counterprovider.count. And there we go. Now I'm going to come back to main.dart and I will simply write counterprovider.currentCount. Alright, let's hot restart the app and increase the value of counter. Okay, that works. And then I'm going to press switch to iOS, and there we go. You can see that the value of counter is conserved. So that's it for our app. Although there is something important left. We made a dispose method in both the block classes, but we haven't utilized them up until now. So come inside of the my homepage state class, and I'm going to override the dispose method, and inside of it I'm going to call the dispose method from both the switch classes. So I'm going to write switch block.dispose and counterblock.dispose. These dispose methods ensure that the streams are successfully closed after the execution of the app to prevent any memory leaks. So this was a tutorial on making the demo Flutter app for both Android and iOS, and experience them on both the devices using the very important block pattern in Flutter. Basically this was an introduction to block pattern. So just for a quick recap, we created two provider classes. One for counter, which provides the current and updated value of counter, and the other provider class provides the current and updated value of the isIOS variable. And then we created a block for both the provider classes. First one is called counter block, which is responsible for creating a stream and putting the updated value of counter on the stream. And then we have the switch block, which also does the same thing, only with the isIOS variable. Then in the main app, we have stream builder widget at the root of the widget hierarchy. And remember, stream builders can only be present inside of a stateful class. So we converted our my app to stateful widget. And then we passed the necessary stream. We passed initial data, and inside of the builder we received the value of OS using snapshot.isIOS variable. And then we created different set of variables for both Android and iOS. Then inside of the counter class, we simply created another stream builder which took the current value of the counter from the stream and rendered it on the UI. So that's it. I also made this UI using a semi-block pattern, so you can check that out as well. It's just a different approach, and it's on a different branch on GitHub for the same repository, which is linked below in the description. Basically, I made use of something called a callback pattern. Let me just show it to you. It's here. So I created my own callback which provided me with the current value of isIOS, and the name of the callback was onOSChanged. Although it was a lot of work, and if you compare running this code versus running the complete block pattern code that we just made, I just felt a bit of a performance improvement for the code that we wrote just now, and it's the ideal way to write something. Anyways, check them out on GitHub, and I hope you learned something of value today. And if you did, then share this video to your tech circle, your colleagues. Also, I love hearing from you, so make sure to comment down below. And if you just discovered this channel, then make sure to hit that subscribe button and check out some other tutorials. I'm sure you would like them as well. So thanks for watching the video and see you soon.